Here we have pre-calculus problem. Okay, let's go to the question. If NP8 to NP7 equals to 4 to 1, what is the value of n? Here two ratios are equal. In the ratio on the left side, we have permutations as the terms. So here we have the permutation NP8 and here we have the permutation NP7. Okay, now in this equation, we have to find the value of n. Okay, now let me write the given equation as it is. That is NP8 to NP7 equals to 4 to 1. Okay, now let me write the ratios on both sides as fractions. Then I'm getting NP8 divided by NP7 equals to 4 over 1. Okay, now let's find the value of this NP8 and NP7. For that, we can use the formula of permutation. That is NPR equals to n factorial divided by n negative r whole factorial. So this is a formula we have to evaluate the value of the permutation. Okay, in our problem, in our equation, at the place of r, we have 8 in numerator and 7 in denominator. Okay, now let me use this formula to get the value of this one. That is n factorial divided by n negative. At the place of r, we have to write 8. So then we get n negative 8, the whole factorial divided by, so n factorial by n negative 7, the whole factorial for the permutation in denominator. So 4 over 1 is just 4. Okay, now what we can do is we can write the fraction in numerator as it is. That is n factorial divided by n negative 8 factorial. And let me change this division over here as multiplication. When I change this division as multiplication, I have to get reciprocal for this one. When I get reciprocal for this one, I am getting n negative 7 factorial divided by n factorial equals to 4. Here this n factorial will cancel. There is 1 times, here 1 times. When I multiply the two numerators 1 and n negative 7 factorial, I am getting n negative 7 the whole factorial. The same thing, I have to multiply the two denominators. So when I multiply this one by 1, still I am getting n negative 8 the whole factorial equals to 4. Okay, now we have to simplify this stuff. For that, we have to expand one of these two factorials. For that, we have to select the one which is bigger in value. So which one is bigger, this one or this one? In both the factorials, we have n, and the first one, in the numerator, 7 has been subtracted from n, but in denominator, 8 has been subtracted from n. Okay, to conclude the one which is bigger, we have to consider the factorial where a smaller number is subtracted from n. So clearly this one, because here compared to 8, 7 is smaller. Since a smaller number is subtracted from n, so this is a bigger one. Now we have to expand this factorial. Usually when I want to expand a factor, for example, let me consider, I want to expand the factorial, that is 7 factorial. For that, what I have to do is I have to reduce the 7 for the consecutive integers up to 1, that is 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1. Okay, so whenever I want to evaluate a factor of a number, so I have to write the consecutive integers in descending order from the given integer to 1. If I want to write 5 factorial, I have to write 5 times, 4 times, 3 times, 2 times 1, up to 1 I have to write. In case when I expand the factorial, if I want to stop anywhere in the middle, that is instead of going up to 1, for example, I want to stop at 4. So I must take factorial over there so that it can be understood it continues up to 1. So the same logic we can do over here. Now I am going to expand this factorial because compared to this one, so n negative 7 factorial is bigger. So when I expand this one, n negative 7 will be the first one. That is, I have to reduce this n negative 7 for the next consecutive integers up to 1. Okay, n negative 7. So to get the next integer, what I have to do is I have to subtract 1 from this one, because when I expand 7 factorial, first I write this integer 7 as it is. Now to get the next one, I subtract 1 from this 7, I get 6. The same logic. When I subtract 1 from this n negative 7, what do I get? I am getting n negative 8. So as negative 7, negative 1 can be combined as negative 8. So the next one is n negative 8. And if I want to get the next one, I have to subtract 1 from this n negative 8. It will be n negative 9. So to get the next one, I have to subtract 1 from this one. I will be getting n negative 1. So in this way, it will keep going up to 1. But if I want to stop anywhere in the middle, I must take factorial. Okay, now let me stop at n negative 8. So then I have to take factorial over here. So here we have a question. Why do we stop particularly at the term n negative 8? Because we have n negative 8 factorial in denominator. That's the reason I stop at n negative 8 over here equals to 4. So this n negative 8 factorial, n negative 8 factorial will cancel out. Then I'm getting n negative 7 on the left side. On the right side, we have 4. Okay, let me add 7 to both sides. When I do so, this negative 7, positive 7 will cancel out. N equals to, here when I combine this 4 and positive 7, I'm getting 11. Okay, in the given equation, I got the value of n. The value of n is 11. We find 11 in answer choice C. The correct answer choice for this question is C.